So today we are going to work on another type of factoring, which is leading us into quadratics.
Is there stuff we haven't learned in the school year that like we would usually learn with a no COVID-free?
Yeah, there were some things that we took out for time purposes, but nothing that'll hurt you for next year.
Finn's been quarantined, right?
No,
I don't think so.
I've never been quarantined.
How did you? So tell me how you got hit with that baseball. Was it the pitcher?
No, I just turned my leg and maybe.
Can you see the bruise on his leg?
Where?
On the back of his leg. It looks like it hurt real bad.
Is it marker?
It's just marker. Just marker.
Looks like it hurt.
Yeah, it was big.
Okay, so we have some terminology here.
You didn't catch it, bud?
Who is it? I was batting.
Catch it with your hand.
Well, you didn't tell me if you were batting or not.
Thought it would be given that you'd know.
No, I just thought you were that type of kid to just never catch
Yep. Oh, you got me. I'm not kidding.
it. You know.
So we've been factoring, right? And some of the things about factoring is there's no equal sign. It's an expression, not an equation. And also our answers were left as quantities. Like x plus 2 times x minus 3 or something like that. So that's what we've been doing. We're going to step it up a little bit. One of the things about these polynomials we've been doing is that they have an interesting looking graph. Okay, so up until now your graphs just had like straight lines, right? A linear equation, straight line. Remember, in order for it to be considered a linear equation, there's no exponents. Well, we've been dealing with polynomials that have exponents. Okay, so what we're going to do is we're going to use this factoring to figure out what the graph would look like. And the graph is called a parabola. So I'll show you examples of that in a second. We've been doing factoring. That's just where you stop. And then factoring completely. Or they'd say solve is what we're going to be doing this today. You'll know that you need to solve it because there will be an equal sign. Answers will be as a one-digit value. Okay, so you already have the skills. You know how to factor things. Now we're just taking it one step further, and what we're finding are what's called the zeros or roots. So I'm going to draw a picture now on a separate piece of paper. Don't put this in your notes. Okay, it's just kind of this is where we're headed. This is how this will eventually play out in the next couple days. All right. So if I have the quantity x squared minus 10, don't write this in your notes. This doesn't go to your notes. Minus 10x. Nope, that's not going to work. Minus 6x plus 5. Okay. So if I have this, and then I was going to do, all right, well, x minus 5 times x minus 1, right? What times what equals positive 5? What plus what equals negative 6? So this is where you guys would be without AC method. Everybody with me? What times what plus what.
Mhm.
So then I'm going to take these two quantities, it's equal to 0, and I'm going to put them equal to 0, x minus 5, x minus 1. Then I'm going to solve for x. So I would add 5 to both sides. This is just a one-step equation. You guys are really good at these. Add 1 to both sides. Again, a one-step equation. And I have these two values that are my one-digit value answers. These two values are called zeros, also known as roots, because they are going to be my x-intercepts if I had a parabola. You guys have seen graphs like this that kind of go whoop. You can't see it, right? So here's my 1 and here's my 5. So these values are becoming my x-intercepts. They're called zeros because what's the y value? 0, right? They're called roots because they're kind of like the foundation of the parabola. The only thing we don't have yet is how to create this vertex here, what the vertex would be. There's a cute little formula for that. We're not going to worry about that today. Where we're headed is to find out our x values so we know what our x-intercepts are of our parabola. I'm not going to have you do any graphing today. I just wanted you to know what these x's will stand for. Also known as roots, also known as zeros. Lots of different aliases. Okay, let's go back to this. We'll jump into some examples. Some of you look a little bit nervous about this. Don't be. You're going to be fine. Tired's okay. Tired is totally fine. Okay, let's see if I can find a good one. All right, let's try x squared plus 1x plus, minus 12. Equals 0. Okay, so I'm going to ask myself, what times what equals negative 12? What plus what equals 1?
Negative.
Over and 3, negative 3 and 4.
Yep. Negative 3 and 4, negative 3 and 4. So I get these two quantities, x minus 3 times x plus 4. But because this has an equal sign here, that means I need to take these two quantities a step further and figure out what the x values would be. So I'm going to do x minus 3 equals 0, x plus 4 equals 0. It's a one-step equation, right? So add 3 to both sides. I'm left with x equals 3. Subtract 4 from both sides. I'm left with x equals negative 4. So what that tells me is if I were to graph this, my x-intercepts would be 3, 0 and negative 4, 0. Right? I don't know how high the parabola goes, so if we were to graph it, let's just draw a little picture here.
How would you know if the parabola would be negative or positive?
So there's a little formula to find the vertex. Whatever you get for that, that tells you if you dip down or if you go up for a peak. Yep. So I would have 3. This would be 1 intercept and then negative 4.
Do you want us to draw this?
Yep. Go ahead and draw it. That's how I get my x-intercepts. right? We just don't know where to put the vertex yet, so we can't draw the parabola. Like I said, there is a formula for that. We're just not ready there yet. Not bad, right? Just taking it one step further. You guys got this? Yeah. Okay, let's go on to the next example. All right, so let's say we have x squared
He's saying it out loud.
Oh, you guys can't see it, can you? All right. X squared plus 8x minus 15. That doesn't make sense. Hold on. Plus 2x. There we go. So I can ask myself, what times what equals negative 15? What plus what equals 2?
Oh, I did the last one. I don't know this
Yeah, I
one.
know the last
The
one.
last one worked too.
Did it?
Yeah, it's like
Yeah.
3 and 5.
But the negatives wouldn't give you positive 8,
Oh,
right? Because it had to be negative 15.
Oh,
that, that's what I
It's still going to be 5 and 3.
-5. Oh,
5 and negative 3. Yeah?
Same.
So x plus 5 times x minus 3.
Yeah.
There is supposed to be equal 0 in the equation. Thank you. So then I'll do my one-step equation.
are we drawing that graph again?
We can, sure. Anybody see a pattern of what's happening between our quantity and our x-intercept?
One negative, one is not negative.
Okay. What did they start out with?
They switch,
Like the negative
Yeah.
5.
Yeah, they're the opposite value.
yeah, that's what I'm saying, but like, not as a good way.
Okay. What about if I give you just the quantities? What if I said we did all that work and we ended up with 2x plus 3 times x minus 4. And we'll just say equals 0. What am I going to have to do to these two? I can't just switch them. I mean, I can for one of them.
How are we writing this one?
Divide it or find the greatest common factor.
Well, I'm just going to put 2x plus 3 equals 0 and x minus 4 equals 0. So this one is easy. I'm just still doing the opposite value because there's no coefficient. The next one requires a little more work because it's a two-stepper. And this gives me an x-intercept of a fraction, which is fine. It's not pretty, but it's fine.
So you just divide divide the x by the number?
I'm not sure what you mean by divide the x by the number. So which digits are you dividing?
The 2 and the 3, right?
Mm-hmm. But then you have to remember that it has to be negative. So you do 3 divided by the 2 and make it negative, right? So my my x-intercepts here. It's going to be negative 3 over 2, which is basically going to be negative 1.5, and then positive 4. How are we feeling about zeros and roots? Roots and zeros. Not terrible, right? It could be a lot worse. Okay, we're going to up our game a little bit. You're going to be fine. 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 All right. Let's go to the next page.
Secret message.
What did you want to say?
TJ told me to say
No, no.
You guys hoping to say something to Adam? No?
How about the secret message is loser?
No, we're not doing that.
Like
It's a terrible
G-
secret
like-
message.
Like G is a loser.
No. I'm not even, no. And I apologize if he's actually watching right now and heard that.
Sorry, G.
Nobody's a loser.
Well, that's what he gets for calling me a salamander.
When did he call you a salamander?
You just made it
He
look
calls
like
it that like every week on your stuff.
Literally.
What?
DJ is salamander.
I don't, have I heard?
So the code should be G is a loser. Shout out to TJ.
G equals
Okay.
L.
G
Okay, I
equals
think he,
L.
okay, we'll just leave it like that. Why does he call you a salamander?
Don't know.
Yeah, it was.
says that TJ looks like a salamander.
You do not look like a
I
salamander.
mean, it's not.
Shut up, Finn.
No. Okay, so this one's a little bit different because this has a greatest common factor. What would my greatest common factor be here?
5x.
Yep.
You guys all said 5.
So we're going to take the 5x out and we get x squared minus 6x plus 8 equals 0.
What does he do when he's not here?
Yeah, that's what I'm wondering.
I've heard that quarantine can be very boring.
It wasn't for me.
What'd you do, TJ?
You have to like
I went
email
to the gym
teachers.
every day.
TJ, you're
You did not. Did you?
Huh?
Did you really go to the gym every day?
I mean, I didn't have it, so.
You didn't know you didn't have it.
Well,
Well,
No, he didn't.
when I went to the gym, it wasn't even like me and my dad were just like distance off from everybody.
Wait, what's your
okay, back to our example here. What times what equals 8? And when you add it, you get negative 6. Negative 2, negative 4.
I saw
Negative
G
2,
in
negative
practice.
4. So we have x minus 2 times x minus 4. We bring down the 5x. Okay, this is where it gets a little different.
I saw him.
We now have to make 3 things equal to 0. 5x equals 0. X minus 2 equals 0. X minus 4 equals 0. When I divide by 5, I'm going to get x equals 0. Add the 2's, I'm going to get x equals 2. Add the 4s, I'm going to get x equals 4. So probably what you're thinking is, why are there 3 x-intercepts, right?
One of them's 0, so like.
It's still crossing the line at the x-axis. So if I were to draw this, I'm going to have an x-intercept at 0, x-intercept at 2, and then x-intercept at 4. So what this means is, and I don't know the vertices, but it would increase and decrease and increase again. It's going to be like a squiggle. Okay? There's a lot of extra mathing that goes into figuring out what the vertices would be, but we're just going to know that that's what it would look like. We can pretend it might be like that. And then last class was like, well, couldn't it go the other way? It could. It could go down and then up and then down.
Can it go up twice? Or no?
No, because it has to come down to another vertex. So it's got to have vertices in each direction. It can't just be like a M.
He has increased vision.
I see that one.
What are you guys looking at?
TJ has increased vision.
I see the one that says Michelle Martian Ashton will Noble's little sign up top.
Don't say Michelle, it says Michael.
Same thing.
You can see, but can't read.
Wait, where are you looking at?
Now I
It
see
says right there.
the lacrosse.
Oh, are you talking about the awards?
Yeah, I see the thing that says response. So.
He's testing his increased vision.
Okay.
Well, shut up. And what?
Why does he have increased vision?
Yeah.
Okay, let's do another example here. We have another greatest common factor. What is it? X. Yep. So x times x squared minus 7x plus 12 equals 0. So then I'm going to say what times what equals 12, what plus what equals negative 7.
-3 and -4.
Yep. So I've got x minus 3 times x minus 4. I have to bring the x down, and I set it up equal to 0. So I've got x equals 0, x minus 3 equals 0, and x minus 4 equals 0. Can't do anything else with x equals 0.